A small difference can have a big impact. Imagine a car with a slight misalignment issue, just a single degree. A 1-degree change in thrust angle will deviate from forward-facing cameras or radars 63 inches at 100 yards. This slight deviation could lead to a catastrophic event and jeopardize your customer's safety. Your customer's safety should be paramount in all repair decisions, so it is critically important that your shop understand and repair the vehicle to manufacturer's specifications while also properly documenting every step of your process. This includes repairing and calibrating all the advanced driver assistance systems, commonly known as ADAS, on every ADAS-equipped vehicle you repair. Since this can be a complex technology, we've created a process to help you identify and address when vehicles should be calibrated and ensure they don't have the slightest difference from how the manufacturers designed them to operate, and assist you to create all the documentation needed to have confidence that the vehicle's safety systems were calibrated properly. This process will guide you through 12 steps to calibrate and document all ADAS systems on a vehicle. Step 1. Consult with the customer and ask if they are aware of any ADAS features that are inoperable or if they have disabled any features. Review, research, and do a pre-scan. Document your pre-scan findings, including pre-existing or unrelated damage. Step 2. Make a checklist of the vehicle's ADAS options and features with either visual verification or vehicle manufacturer's build data, or both. Step 3. Consider repairs. Keep in mind that the disassembly or removal of various components may affect the system's operation. Consult the vehicle manufacturer's service information and experts, such as an ADAS specialist, on which ADAS systems will need to be included in the repair and calibration process. Document any additional calibrations needed to ensure an accurate blueprint. ADAS repair personnel should coordinate with collision repair personnel to ensure that components are left exposed when required by the vehicle's manufacturer's prescribed procedures. Proceed with collision repairs. Step 4. After completing the collision repairs and reassembly, except for components that should be left exposed, scan the vehicle, assess and address any diagnostic codes, and document. Step 5. Complete and document any needed initialization, programming, and module setup processes. Step 6. Perform post-repair scans, address and clear codes as appropriate, and document with a virtual printout. Perform post-scan again to ensure codes are cleared. Step 7. Use the vehicle manufacturer's calibration procedures to identify calibration preconditions. This would include things like tire pressure, proper wheel alignment, fuel level, etc. Step 8. Ensure all preconditions requirements are met and document that the conditions were met with date, time, and personnel involved. Step 9. Complete dynamic and static calibrations and make sure you document the steps that you followed using video recordings or photos. Step 10. Coordinate with collision repair personnel to ensure that any necessary vehicle assembly is completed. Step 11. Test the vehicle's ADAS system's functionality by performing a dynamic systems verification, also known as DSV, in conjunction with a road test. A DSV identifies and confirms the performance of all the vehicle's ADAS systems and features, such as adaptive cruise control, blind spot monitoring, lane keep, and lane watch systems. A complete list of the features of each vehicle can be found in the owner's manual or vehicle service information. Only qualified personnel who have become familiar with the vehicle's ADAS systems and functionality should perform a DSV. Step 12. After the vehicle passes the DSV, complete a final scan, perform your quality control processes, and review the ADAS features with the customer, documenting that they've been set to the vehicle manufacturer's specifications and turned on. Inform the customer that they may want to adjust the system settings to their preferences. Following these critical steps ensures that all ADAS features have been calibrated properly and documented clearly. It's a small difference that has a big impact. Thanks to all the many members of the SECA ADAS Calibrations Committee and the CIC Emerging Technologies Committee. Special thanks to the following members: Daryl Amberson of Lametries Collision, Gene Lopez of Seidner's Collision Centers, Chuck Olson of Air Pro Diagnostics, and Charlie Quirt